Today we are going to discuss uh, the transaction processing. Yesterday I told you about transactions, and now we are going to discuss transaction processing, how the transaction can be processed. So as you know, there are single user systems and multi-user systems. When you are using a single user system, the processor time is entirely allocated for that single user, and in that case there is no need for interleaved processor allocation. And multi-user systems, many users can access the system concurrently. Suppose that if you have a database and the database is shared among different users, then a number of users are trying to access the multi-user system at the same time. So then there is a need for concurrency. So that concurrency has to be controlled. Concurrency in the sense that means a number of users are using the system at the same time or trying to access a particular resource at the same time. That is called concurrency. As far as dbms is concerned, there are two types of concurrency. Interleaved processing means concurrent execution of processes interleaved in a single CPU. That means you have only one CPU, and that CPU time is shared among different processors. Then other one is parallel processing. Processes are concurrently executed in multiple CPUs. That means instead of having a single CPU, you have multiple CPUs. Now, what is a transaction? Logical unit of database processing that includes one or more access operations. So, typically we have two types of operations, read and write. Read is retrieving information from the database, and writing means we are either inserting or updating or deleting the database. In either case, that will be treated as a write operation. Okay. If you are reading data, that means non-destructive, that means nothing is changed. But if you are processing, if you are using a write operation, then you are either inserting, updating or a deletion. Okay. Now, a transaction may be standalone, specified in a high-level language, or like SQL submitted interactively, or may be embedded within a program. That means if you have a database request, either a read request or a write request, that can be a transaction, a set of operations, standalone operation. That means you are going to write transaction processing code, or it may be embedded in a high-level language. Okay. Then transaction boundaries. A transaction starts with a begin transaction and it is ending with an end transaction. An application program may contain several transactions separated by begin and end transaction boundaries. That means in between begin transaction and end transaction, there are a number of statements. That is okay. Then introduction to transaction processing is continuing. Simple model of a database for the purpose of discussing transactions. A database is a collection of named data items. For example, database is having a set of tables, and in that set of tables you have a set of attributes as well as a set of tuples. Then what do you mean by granularity of data? A field, a record or a whole disk block. That means granularity means that may be a single name, single age value or single value, or a record as a whole. That means that is a tuple or a whole disk block. That means granularity means granularity of data can be either a field, a record or a whole disk. Okay. Then basic operations are read and write, as I told you. Read item X means reads a data item named X onto a program variable. To simplify our notation, we assume that the program variable is also named X. That means you are reading an item X. And write item X means write the value of program variable X into the data item named X. That means here the variable name and the database item are having the same name. Okay. Now, read and write operations. Basic unit of data transfer from the disk to the computer main memory is one block. That means reading as well as writing is done as a block. Okay. That means suppose that the block size is say 512 bytes. Then you can either read data as 512 bytes, or you are writing data as a 512 bytes unit. That is called a block. In general, a data item will be the field of some record in the database. Also it may be larger units such as a record or even a whole block. Read item X commands includes the following steps. So suppose that if you want to read a data item from the disk, so first of all you have to find the address of the disk block that contains the value X. That means address of the disk block means in which cylinder it is and it resides, and which is the block, which is the sector number, and then we have to find out the block address. Copy that disk block into a buffer. That means you are going to reserve a portion of the memory, main memory, for receiving or for bringing the secondary storage block, and it is read to the primary memory, and from that primary memory you are going to read that item. That means reading from secondary storage to primary storage is done as a block. Copy item X from the buffer to the program variable named X. Then read and write operations continued. Write item X. That means again finding the address of the disk block that contains the item X. Then copy the disk block into the buffer in the main memory. Again, for which data item you are going to make the corrections, you are going to do that in the block. Then that is returned back to, or you are storing the updated block from the buffer back to disks. That means initially you are going to bring the buffer, bring the block to main memory, then doing the write operation, then that is returned back to the, or you are storing that back to your secondary storage device. Two sample transactions. This is an example of transaction 1 and transaction 2. Transaction 1 is reading an T1, reading an item X. That means now you have copied the content of a particular disk block which contains that X to the main memory. Then X assigned equal to X minus n means that X is decremented by n. Then write item X. That means you are going to write this back to X. Then again reading an item, another item Y, you are going to increment that by n, and again writing that back to Y. And T2 is reading the item X. That means these two transactions share the same variable X. Now we are reading the value of X, then X is incremented by M and writing that back to X. So these are two transactions. Now when you are doing concurrency, concurrent programming or concurrent execution of transactions, then you have a number of problems, and for overcoming those problems, concurrency should be controlled. What is lost update problem? This occurs when two transactions that access the same database item have their operations interleaved in a way that makes the value of some database item incorrect. I will show you how lost update. This is the lost update problem. That means here see, initially time is starting from T1, and after executing two statements of T1, it is then two statements of T2 is executing. After that, two statements of T1 is executing. After that, one statement of T2, and after that, the two statements of T1, like that. So read item X, X assigned equal to X minus n. That is the first two. Then there is no problem. That means when you are reading that item X, that means you are bringing the content of that X, that block, to the main memory. Then in the main memory you are going to have this decrementation. That means you have decremented that value by X. Suppose that the initial value of X is say 100, and suppose that the initial value of n is say 10, and suppose that the value of m is say 20. Suppose that the values of X equal to 100, n is equal to 10 and m is equal to 20. What will happen? When you are reading item, that means I am talking about transaction T1. Read item X means we are reading the content of X, and now the value of X is 100, and that is copied to the main memory. Then in the main memory you are going to have this decrementation, that is x assigned equal to x minus n, means in the primary, in the copy of that block you have done that decrementation. That means now x is 90 in the copy, not on the original database. After that T2 is doing, and T2 read item x means T2 is reading, that means reading from the secondary storage, and in the secondary storage now again the value of x, that means no updation, nothing is updated. That means when you are writing that item back to x, then only that will be updated. Okay, now when you are reading the item x, what will happen? Again the value of x is 100. That means you are going to have a copy of the buffer, copy of the block, and in that x is x equal to 100, and when you are incrementing that by m, that means that becomes x is equal to 120. That means 100 plus 20 is equal to 120. After that it will come back to write item x, means in that write item x, when that x is after decrementing x, when you are updating that x, what will be the value of x? That means in the secondary storage, when T1 is updating using the write item x, there the value in the secondary storage now it is 90, x is 90, and read item y, again reading an item y, and that means reading by, it is not a shared variable, so we are not interested in that variable. After that write item x means when T2 is writing that item x, what will happen? Then after reading the value of x was incremented by m. When it was reading the value of x, the value of x is 100, and 100 is incremented by 20, and when you are writing that item back to x by T2, the value of x is 120. Okay, now see actually what it has to be. Plus after T1, if you are doing T2, after execution of T1, write item x will be 90, and now if you are incrementing in T2, if you are incrementing that by 20, that should be 110. But now the value of x after this interleaved operation of T1 and T2, the value will be 120. That means some updates, that means updates by T1 is lost. Updates by T1 is lost. That means update of T1 is overwritten by T2. That means this is called lost update problem. Now next one is temporary update or dirty read problem. First problem is lost update, and second one is temporary update or dirty read problem. This occurs when one transaction updates a database item and then the transaction fails for some reason. The updated item is accessed by another transaction before it is changed back to its original value. That means if a transaction fails, and then it has to roll back or revert to its previous consistent state. So before doing that, so if some other transaction is using that variable, then we will have this temporary update problem. That means this is temporary update problem. That means here T1 and T2 are executing in an interleaved fashion. Now x is reading, suppose that the value of x is 100 and n is again set 10. Then x is, after that the value of x is 90. Then when T2 is reading that value 90, and it is doing some operations. Suppose that after executing write item x of T1, T2 is reading the value of x, and at that point in time, suppose that the transaction T1 fails for some reason. Transaction T1 fails and must change the value of x. That means you have a begin transaction statement and an end transaction statement. If in between begin transaction and end transaction, if something extraordinary happens, then that transaction has to be rolled back or reverted, and it has to roll back to its previous consistent state. That means the previous value of x is 100, so that 100 has to be restored. So when you are executing these three statements, read item x, x is equal to x minus n, and write item x, the value of x is updated and that value is read by t2, and t2 is again incrementing that value by 20. Now write item x means now the value of x is 110, but in between T1, the transaction T1 fails and transaction has to revert back to its earlier consistent state, and in that state the value of x is 100 and the value read by T2 would have been 100, but instead it has read a dirty value, that is called temporary update problem. And the third one is lost update problem, temporary update or dirty read. That means the transaction T2 is reading a dirty value. That means after updation by T1, the value is read by T2, and in between, before ending the transaction, the T1 has aborted. T1 has aborted means it has to revert back to its original x, and original x is 100. Instead, T2 has read that value as 90. That is called dirty read. Now the next one is the incorrect summary problem. If one transaction is calculating an aggregate summary function on a number of records while other transactions are updating some of these records, the aggregate function may calculate some values before they are updated and the others after they are updated. So I will show you an example. This is the example. That means T3 is continuously calculating the value of the sum. T3 is continuously calculating the value of sum, and as far as T1, transaction T1 is concerned, here this is read item x, x is equal to x minus n, and write item x. Here this transaction T1 is updating the value of x, and that is decrementing x by n. And after that, T3 is reading the item x. That means the value of item x is right. That means sum assigned equals sum plus x. And before updating, in T1, in T1 it is updating the value of y as well, but the value of y is also updated, and before updating the value of y, again T3 is calculating sum assigned equals sum plus y. Actually either T1 should do this as a whole, as a single unit. That means updating the value of x as well as y has to be done as a single unit, and after that T3 has to read the value of x and y. Here the value y has read is an incorrect value. That is called incorrect summary problem. And now we are going to discuss what you mean by recovery. Why recovery is needed? That means a computer failed or a system crash. That means when you are doing something, then in between there may be a system crash. That means computer failure, whether it is hardware failure or software failure or something like that. Hardware or software error occurs in the computer system during transaction execution, and if the hardware crashes, the contents of the computer's internal memory may be lost. Next is a transaction or system error. Some operation in the transaction may cause it to fail, such as integer overflow or division by zero. Integer overflow is a typical error, and division by zero is also a typical error. And transaction failure may also occur because of erroneous parameter values or because of logical programming error. In addition, the user may interrupt the transaction during its execution. That means a computer failure can occur, or a transaction or system error can occur. Then local errors or exception condition detected by the transaction. Certain condition necessitate cancellation of the transaction. That means, suppose that if you are reducing or if you are debiting from suppose that you are in your balance, suppose that you have only 100 rupees, and suppose that you are going to debit say 200 rupees, then that transaction has to be aborted. And like that, a certain condition necessitate cancellation of the transaction. For example, data for the transaction may not be found. A condition such as insufficient account balance in a banking database may cause a transaction such as fund withdrawal from the account to be cancelled. A programmed abort if the transaction causes it to fail. Okay. Then concurrency control enforcement. Concurrency control method may decide to abort the transaction to be restarted later because it violates serializability or because several transactions are in a state of deadlock. That means if you are enforcing concurrency control, there may be if it violates serializability, then concurrency control has to be enforced, and if there are several transactions in the deadlock state, again concurrency control has to be enforced. Okay. Then next one is recovery is needed if there is a disk failure. Some disk blocks may lose their data because of a read or write malfunction or because of disk read or head crash. This may happen during read or a write operation of the transaction. Physical problems and catastrophes. This refers to an endless list of problems that includes power or air condition failure, fire, theft, sabotage, overwriting this or taps by mistake, and mounting of a wrong tape by the operator. These are all causes of system failure, and because of this recovery is needed. Recovery, that means you should be able to recover the lost database in a consistent manner. Okay. That is the need for recovery. Okay.